Hey everyone, and welcome to this explainer. If you've been writing in C for any amount of time, you've definitely used printf. I mean, it's practically a reflex, right? But honestly, from the outside, it kind of feels like magic. Well, today we are going to strip away all that magic. We're going to reverse engineer the famous ft_printf project and turn you from a beginner programmer into a true systems architect. So, here is the absolute fundamental question we have to ask ourselves before we write a single line of code. Think about it for a second. How does one single function handle an unpredictable number of arguments of totally different types? You can pass it a string, a couple of integers, and a memory address all at the exact same time, and it just works. It's wild. I want to acknowledge that mystery right up front, but our goal today is to demystify it layer by layer and show you that this so-called magic is really just beautifully organized logic. All right, here's our roadmap for today. We'll start with the printf magic, move on to Variadic macros, look at the core engine, dive deep into recursion and hex, tackle pointers, and wrap up with a solid developer game plan. Okay, let's jump right into section 1, the printf magic, where we map out our mandatory conversions. You know, you really can't build a house without a blueprint, and this table, this is your blueprint. Here's the full matrix of the mandatory conversions we need to build for this project. We're going to be translating everything from simple single characters using %c all the way to raw memory addresses with %p. In between, we've got our standard decimals and integers, unsigned numbers, and those tricky little hexadecimal formats in both lowercase and uppercase. Oh, and obviously we need a way to print an actual literal % sign. Keep this checklist in the back of your mind because this is exactly what our function needs to conquer. Moving right along to section 2, mastering variadic function macros. This is all about unlocking that invisible list of arguments. So how exactly do we pass an invisible, infinite list of variables into a function? We use a super powerful C concept called variadic functions. Look really closely at the standard C prototype here. Do you see those 3 dots right at the end? That ellipsis is essentially a secret handshake with the compiler. It tells C, hey, after this initial format string, our ft_printf function is allowed to just swallow up as many extra arguments as we throw at it. It's an open door. But once they're inside, how do we actually grab them in the code? Well, that brings us to the macros that manage these received arguments. Let's completely demystify this jargon. I want you to think of the incoming arguments as a hidden stack of cards. Step 1 is via start. This initializes the list. It basically gets you ready to draw from the deck. Step 2 is via arg. This grabs the actual next argument in line. Every single time you call it, it hands you the next card off the top. But there's a catch. You have to tell it exactly what data type to expect. And finally, step 3, via end. This cleans up the list when you're done. Whatever you do, do not forget this step, or you're going to experience the classic C programmer's nightmare, a massive memory leak. Honestly, once you get the hang of it, it's a really elegant 3-step dance. Oh, and here is a massive developer tip for beginners. This trips up almost everyone. When you're using var arg to grab a character for your %c conversion, logic tells you that you should ask for a char, right? Actually, no. You need to grab an int. Why? It's because of a quirky rule in C called automatic type promotion. Basically, any type smaller than an integer, like a char, gets automatically promoted up to an int when it passes through those Variadic dots. Good to know. All right, section 3, building the core engine. I really like using a traffic cop metaphor to explain parsing here. Imagine your parser is a traffic cop standing right in the middle of your format string, watching the characters drive by one. If a normal, everyday character drives up, the cop just waves it right through, meaning you just print it to the screen immediately. But if a % sign rolls up, the cop blows the whistle and stops traffic. That % sign is a major alert. The parser then checks the very next character's ID. Is it an S, an X, a D? Once it knows, it routes that traffic down the correct road to the right handler function. So what does this actually look like in code? Here's the minimal skeleton of your main ft_printf.c file. You initialize your variables and hit va_start. Then you start a simple while loop to read through the format string. Now this is absolutely crucial. You must track a running count of every single character you print. Why? Because the real printf literally returns the total number of characters it printed. When your loop hits a % sign, you delegate the heavy lifting to a helper function, maybe call it ft_handle_format, which processes the conversion and adds to your running tally. When the string is done, you clean up with va end and return your grand total. Simple, right? Okay, deep breath. Section 4, recursion and hexadecimal printing. This is definitely the technical climax of the whole project. For our %x conversions, we are tasked with converting standard base 10 numbers, the numbers we use every day, like 255, into base 16. Base 16 represents values using numbers 0 through 9, and then it switches to the letters A through F. So in base 10, it's 255, but in hexadecimal, that becomes FF. But the big question is, how do we actually write code that figures this out dynamically? The absolute best way to do this is recursion. Honestly, this brilliantly highlights the sheer power of recursive programming for number conversion. Here are the 3 steps. First, you check if your number n is greater than or equal to 16. If it is, step 2. You recursively call the exact same function again, but you pass it n divided by 16. This essentially drills down to the most significant digit. Then, step 3, on the way back out of that recursion, you take the remainder, which is n modulo 16, and you use that remainder as an index to print a character directly from your base string, which is literally just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, ABC. It peels the number apart layer by layer, and it prints the hexadecimal in the exact correct order. It is so satisfying when you get it working. Awesome. Let's look at Section 5, Handling Pointers and Memory. We're going to see how reusing our recursive logic saves the day here. To format a memory pointer, there are 3 very specific steps we need to take. First, your Variadic macro is going to grab the argument, and you need to grab it as a void star pointer. Second, standard printf behavior dictates that memory addresses absolutely must start with a 0x prefix, so you're literally just going to print that string, 0x. Third, you convert the memory address itself to hexadecimal. But pay close attention here. You have to cast that pointer to an unsigned long so the variable is actually big enough to safely hold the massive size of a modern memory address. Now here is the real magic trick. I love this. Step 3, that is entirely reused code. You don't need to reinvent the wheel for pointers. You just take that unsigned long and feed it straight back into the recursive hexadecimal function you just built a minute ago. Boom. Pointers solved. Finally, Section 6, the developer game plan. Let's talk architecture, implementation order, and coding defensively. First up is organization. Please, I am begging you, do not stuff your entire project into one massive file. Think like an architect. Separate your logic into dedicated files. Make one for characters, one for strings, one for your standard numbers, one for hexadecimals, and one for pointers, tied together with a single header file. Doing this ensures your project stays clean, modular, and, trust me on this, way easier to debug when things inevitably break. Next is the recommended order of implementation. Do not just pick conversions at random, and definitely don't jump straight to pointers. Follow this specific sequence. Build your foundation first. Start with basic characters, strings, and the literal %sign. Then, scale up to your standard base 10 integers. Once those work perfectly, implement unsigned numbers. Next, you tackle that recursive logic with your hexadecimals, and finally, finish off with pointers because they literally just reuse your hex logic. Stepping through the project exactly like this builds your confidence and totally prevents you from getting overwhelmed by complex bugs.
And lastly, we need to talk about the developer mindset. A real programmer codes defensively. You have to ruthlessly test your edge cases. What happens if someone passes a null string to your function? What if they pass the number exactly 0? What about the absolute maximum or minimum limits of an integer? If you don't test these weird extremes, the automated grading systems are absolutely going to destroy your code. Test all of these. And always compare your output, character for literal character, against the original standard printf.
All right, we've covered a lot of ground. You've got the map, you now understand how Variadic functions pull in invisible arguments, you see how the parsing engine routes traffic, you've grasped how recursive base conversions peel numbers apart, and you know the exact mindset and order required to build this cleanly. The magic is gone. All that remains is the logic. Your blueprint is complete and your tools are ready. So the only question left for you is, will your ft_printf perfectly match the original? Get out there, start coding, and I'll catch you in the next explainer.